Welcome back to Chips and Salsa, where we talk about security topics with Intel employees who are the experts in the industry. I'm CRob,
I'm Jerry.
and this is our second episode in our series on the Intel Storm Team. Storm Team stands for the Strategic Offensive Research and Mitigations. You can find the first video we did with Henrique Kawakami at the link below.
Yeah, so Storm is part of Intel's strategic investment in security, and the team has some of the top, offensive security researchers in the industry. Today, we're talking to Joao Moreira, who heads up the Security Principled Engineering and Research team, otherwise known as SPEAR. Joao, welcome to the show. How are you today?
Hi, I'm thrilled to be here. Thank you for the invitation. I'm doing good. What about you?
We're all good.
Awesome.
Can you give us a little background about yourself and how you came to Intel and the Storm team?
Yeah, absolutely. Well, originally I was mostly like involved in academia kind of research. So I did a PhD back in Brazil at the University of Campinas, and also worked with a little bit with some people in the Columbia University at the time. And I was like mostly doing research on operating systems and a little bit related to security and compilers. And eventually I finished my PhD and I decided I didn't want to stay in academia anymore. I started working with open source mostly. I started working for SUSE Linux, which is a Linux distribution. And I started working doing toolchain work related to live batching, mostly in user space, but also a little bit in the kernel. And it was totally like by chance. I came to a conference in Canada, and I had some friends living in Portland. And at the time, I just shot a message to a friend who was working at Storm at the time. And they said, yeah, we're going to be in the area. We're going to go down to Portland from Vancouver. And perhaps we could like sit down for a beer or something. And they said, yeah, sure, a beer would work. But why don't you make an interview with Storm and maybe you join the team? And well, it worked out and I'm here now.
Very nice.
Yep.
I used to work with the SUSE security team a lot. It's a good group.
Yeah, I love those people, Marcus Meissner, and they're like very skilled people.
Awesome. Yeah.
Yep.
So, it sounds like you've done quite a lot to get here. Are there any industry groups or you participate in or conferences you've done lately?
Okay. I think that most of the work that we do with Spear is somehow tied to open source projects. I myself or Spear, we're not like directly connected to any specific projects, but we end up like hacking a lot of like operating system kernels, compilers, toolchains, libraries, like runtime libraries. And that's basically because, the work we're trying to do is like trying to research whatever is being used out there, figure out if there's like a better way to improve these components, make them safer, or add like new security features to them, or even like sometimes trying to find a soft spot on them that could be abused by hackers. So it's like really, kind of like dynamic kind of work.
Mm-hmm.
And we like try to communicate with the open source projects, provide feedback on whatever is being discussed, whatever is being proposed as a new feature. And one good example of that, I think it's like the FindIBT work that I have been doing. I started like a few years ago.
Mm-hmm.
And we're basically like trying to improve the way that CT is used by the systems. And we're basically like in constant like contact with the open source community, trying to discuss whatever enablement they are doing, whatever optimization they have on top of that, and basically providing continuous feedback and continuous evaluation of the work that's being done.
That's awesome. I hear you had a pretty big event recently.
Yeah, that's true. You asked about the conference, right? So I don't have like anything scheduled right now. So I presented FindIBT in the last Linux Security Summit. That was like the last time I talked publicly. But for a few months, I'm not gonna go give any talks because I just had like a baby. So I have like a 6-month-old at home. And just taking a bonding leave for a few months, and perhaps when I come back in August, let's see how it goes.
Awesome.
So you mentioned SPEAR team, which stands for Security Principled Engineering and Research. You mentioned a little bit of the work you do. Can you just give us a more of an overview of some of the work Spear is looking at?
Absolutely, yeah. So the offensive work that people do at Storm, like, is it's meant to find security problems, right? And in whatever Intel is developing, or whatever it's like, whatever product is connected to Intel. And it's normally like a very complicated thing for security researchers to develop a lot of the research that's being done, because they need to sort of like stop what they're doing and start like implementing tools that will actually like enable their work. And the idea of Spear is to actually like have people that have this background in creating new tools, or making system components work together. So it's more like it has like a very strong component of engineering tied to it. And it's not like that the offensive security researchers can't do it, but it's just that we want them focused on doing the offensive side of things, while in Spear we're like trying to give them the tools to develop this offensive kind of research properly, or more easily, so we can save them time, and sometimes even a little bit of sanity. And we usually like refer to this as like trying to bridge the gap between offensive security research and systems engineering. And that's more or less our goals.
So, how does this help Intel and our customers, this work you're doing in Spear?
Yeah. So first thing is that, I mean, if you are providing tools, you are basically making the work of the people using these tools easier, and this basically like saves them time, and sometimes make their work like even more precise, so they're able to uh, see the projects that they're like researching more transparently, so they just get these tools. For example, we do like a lot of static analysis tools, and they basically just throw whatever they're analyzing into the tool, and the tool is going to like spit them a big list of probably serious issues or things like this. And by doing that, so basically we're like preventing them from needing to look at a source code, a big bunch of source code, like blindly. So they just have like the pointers to where they should be looking at. And while this like saves them time, it also saves them a lot of sanity, because it's normally like very stressful to just dive into a new project you never heard about before, you don't know much about, and start from like scratch, trying to find soft spots and all of that. So the idea here is that basically, since we do have all this knowledge in systems engineering, we just like are looking into a new component, we put things together and say, yeah, I mean, these are the patterns that we're going to look for, these are the possible ways that we can perhaps provide good inputs for security researchers. Yeah, good. So let's like implement a tool that does that and provide like a nice report, or sometimes even like detect problems automatically,
Mhm.
and give it to them so they can perhaps use it as a starting point. I mean, of course, security work is not like that easy that you can just like implement a tool and solve all the problems, but it's like kind of starting point for them to give the first steps in a more oriented direction.
Yeah, it's super useful. Thank you.
Sure.
Yeah. Does the Spear team contribute any of this kind of work to the industry as a whole?
Yeah, I think that I mean, our connections with the open source are like a very good representative of our return to the industry. So, I mean, first thing I would say is that, I mean, by doing this research together with the open source projects, and like looking at them and discussing with them that they should be doing things differently, is like a big outcome for the industry in general, because a lot of people are using Linux these days, not only on their cell phones but also like on servers, even for gaming platforms. So all these people that are benefiting from whatever we are doing to improve the open source systems, they are they're basically like safer. So that's like a big return to the industry, I guess. Second thing I would mention, I think, is that by the fact that we are like making it easier for Intel security researchers to have their work done in a better way. By doing that, we're basically like ensuring that the products that Intel is developing are safer. So whatever component is out there for people to use, for the industry to use, it's going to be safer, it's going to be better, and yeah, that's like an impact to like all the ecosystem that is around Intel.
Yeah, that makes a lot of sense. Thinking through your body of work, do you have any examples of impactful projects that you can talk about here with our viewers?
Yeah, absolutely. I'll mention a little bit the work we have done with CT. So CT is a new, sort of new extension into Intel CPUs that basically provides something we call control flow integrity. And the idea of CT is that it has like two different components. One is IBT, the other one is a shadow stack. And whenever you have like code pointers inside your program, if these code pointers are in memory that is writable, an attacker can just come and corrupt them and perhaps resurrect the control flow of the program and put it into a state that is not supposed to happen, but that actually kind of makes the attacker get some privilege somehow. And the idea of CT is to exactly like prevent this by defining very specific sets of valid targets for these code pointers. So you can no longer like get a code pointer, corrupt it, and make it point whatever you want in the source code. So we have like a list of actual valid targets for these code pointers. And the way it was taught, I mean, it's like a hardware extension, so it doesn't have like a lot of semantic knowledge about the source code that it's trying to protect. So the work we have been doing is something called Find IBT, and what it basically does is that it takes the IBT extension and makes it like even more hardened in a way that, for example, if you have like a set of 200 possible targets for a code pointer, we just do like a compiler optimization on top of that, and we reduce that, I don't know, to 1/10 of that or something like that. So we reduce it drastically and make it like much harder for attackers to actually redirect control flow arbitrarily in a way to get some advantage out of the corrupted context execution of the program or something like that. That's one of the things we have been doing recently with CT. The other one is we also have been evaluating the enablement of the shadow stack. So I recently had the pleasure to work with a brilliant kernel engineer here at Intel. He's Rick Edgecombe, and he's doing the shadow stack enablement together with Linux. And I have been like trying to look at the way he's enabling things and seeing if I could exploit it somehow. So if I could, for example, disable shadow stack or make it behave in a way it was not supposed to.
Mhm.
And this work, I mean, we have found some issues with the original enablement, and we were able like to fix it like even before it went out of Intel, which
Wow.
is actually a great thing, right? So
Mhm.
that's exactly what we want to do here. So whenever products go outside, they're more robust and all that.
Excellent.
Yeah, really. So, how exactly do you see the intersection between tool chains, operating systems, and security?
Okay. Well, I think there are like two important intersections here. One is that, I mean, these components are like critical to system execution. So if you have like a system, the system will depend on the operating system and the compiler. So you want, for example, that your compiler is not generating code with security flaws in it. So you need to make sure that whatever is being generated there is actually safe, or that your operating system doesn't have like big security flaws that will allow a user to simply like exploit it and get privileged access to your system or things like this. So that's like one big intersection. So these are like critical components that we need to make them more robust. And in that sense, I mean, we need to constantly look at them and make them safer. And the other important perspective here is that, I mean, these components are actually like enablers for security for other components. So, for example, you have programs that are running on top of your operating system. And if the design of your operating system is not like robust enough in a way to make whatever executing on top of it also be inherently robust, then I mean, it doesn't matter how much you look at the program which is running on top of it, because it will ultimately like be relying on a failed design that will eventually like just allow an attacker to break the entire chain of trust inside your system. So I guess that if you think, for example, about compilers, compilers actually like generate the code which is being executed in your system. So if you have a compiler that is able to generate code which is inherently safer, this is also better. So you can always go and implement new mitigations or new ways to make it harder for attackers to exploit that binary which is being generated. That's also great. So yeah, I guess these are like the two most noticeable intersections I see.
Mhm. It's
Very
really
cool.
interesting work. You talked about some analysis tools throughout the course of this conversation. Why do we continuously keep investing in these tools and not just be able to find a silver bullet for security issues?
Well, I guess I wish it was like that simple.
Me too.
Unfortunately, that's not exactly the case. So for every tool we implement, we're like kind of covering one specific corner case, I guess. So imagine, for example, that we are doing static analysis, which is something we do very frequently here at Spear. You were basically like looking at the program, why it's not running. So we're just like taking a look at the source code or the binary and trying to identify security issues there. And because of that, I mean, sometimes you don't know what's the value that a specific variable in the source code is holding. And it doesn't allow you, to know very well what's going on and if that will be an issue or not. So it's a little bit more complicated to do static analysis because it doesn't give you visibility over the execution context of that specific program. On the other hand, if you do like dynamic analysis, you are basically like observing the program while it's running, and you can try to figure out what is the context there, what are the variable values whenever you were intercepting it. You can have like a better view, but again, it's like something really hard to do because you need to have like introspection over the program execution. Some programs like won't give you specific interface for doing that. So imagine if you were like trying to observe a program while it's running inside a very specific and closed hardware component, which is like not supposed to communicate with like an external system except for that very specific task that it's doing. So it doesn't like provide you a way to look at it. So it's normally like very very hard to do this sort of analysis and firmware, for example, and other kernel components that don't provide you debug interfaces as they should be.
Mhm.
Also, I think that there's the thing people call the event horizon, right? So it's like the most like closer you can get to an experiment without actually interfering in it. So, for example, if you were taking a piece of software and you are adding the interfaces for you to observe it while it's executing, are you like actually interfering with its execution,
Mhm.
and will that actually maybe hide a problem from happening? That's, for example, very common if you were like trying to analyze a multi-threaded execution in a way that whatever different operation is executed, be it like for provide you the debug interfaces, it may cause the actual scheduling of the execution to be different, and perhaps the problem will not manifest anymore. So
Mhm.
we have to look at every problem like with a very specific kind of mindset, and look at that, say, yeah, I mean, what can I do for this specific problem? So is this a firmware, is this a server, is this a kernel, is this like a microcode, what is that? So we just need to look at that specific project with the very oriented guidance in a way to look at that and find this specific problems.
Makes sense.
Yeah, that's really interesting and actually really impressive. As an Intel employee, it's awesome to see, you know, the work that the Spear team is doing. So, what's next for Spear?
Okay, so Spear's growing. We recently like have like some new hires coming in. Right now, like I said before, I'm going on bonding leave for my newborn baby. But Spear's probably like trying to close the cycle on the fine IBT research, which is that research I mentioned I started like a few years
Mhm.
ago. Just like see what are like the collaterals that will come from it, because when you were looking at a specific component to that like depth level, you eventually like find new different stuff that could be done in another way inside the compiler. So basically, we're just like trying to collect all of these that need to be addressed. And once we're done with it, we will definitely like start like looking at new components and new instruction sets that perhaps we could be helping, trying to reshape, kind of do a mad scientist kind of work, and see if we can provide or propose new ways of using them that could perhaps like benefit the entire community. So yeah, like I said, I mean, Spear is growing. We had Gabriel who recently joined. He's like doing amazing work with microcode analysis. We have more people joining. So we have Sebastian coming in June, who's probably like looking at compiler mitigations. And yeah, I mean, we're still like have positions available. So if you know about anyone interested in joining Spirit, would be mostly happy to talk to these people.
Sounds like it'd be a really fun job. thank you for coming today and sharing with us. This was amazing to kind of listen and learn from you today.
Absolutely.
Yeah, well-
Thank you for the opportunity to talk the things we're doing.
We'll have to come and get a picture for the website of your mad scientist team.
Lab coats.
Sure. Yeah. I mean, you're all people with like crazy hairs, and all that.
I'll have a problem with that one.
Yeah.
You were making it up,
Yeah. I guess I'm a little behind right there. All right. Thank you again for joining us. This was great information in our continuing series on the Storm team.
Yeah, sounds good. And you definitely want to talk to the rest of the team. I mean, Storm is an amazing place, amazing people there. And it's like really nice to be able to talk about the things we're doing. Thank you so much for the invitation.
Excellent. Thank you.
Sure.
Jerry, I can't describe how cool it is to see the leading edge work our engineers are doing today.
Yeah, totally. And this is just some of the work that the Storm team is engaged in. So in upcoming episodes, we'll talk to more of our elite security researchers about how, they hack Intel products.
Yeah, I'm really looking forward to that. And with that, I think we'll call that a wrap for this episode of Chips and Salsa. Jerry and I want to thank Joao for coming and sharing his time with us about the work he does. And thanks everybody for watching.
Thank you.